Good morning, everyone. Welcome to the Bringing Robotics and Coding to Life in Your Classroom webinar that is hosted by Merconet and Canadian Classroom. My name is Liz Gonzalez, and I will be sharing with you during this webinar. Please do not hesitate to write your questions via the chat, and I will answer them at the end of the webinar. The purpose of this webinar is to present you completely new tools that can boost your classroom experience. We'll give advice on what to look for when searching for the robotic sets for your classroom and present you a review of the most interesting robotics and coding sets currently available. So let's get started. In the first part of the webinar, I'm going to present you some of the most important criteria to look for when choosing your robotics and coding sets. Then, based on that criteria, I'm going to present you new solutions that could be good options for your classroom. The kits I'm going to present you are suitable to teach advanced coding in the preschool, elementary, and secondary school, depending on your student's level. To start, let's take a look at some criteria to use when searching robotics and coding kits for your classroom. You want a kit that comes with good instructions and support from the manufacturer. It is important to buy from reputable companies and check the manufacturer's website for downloadable manuals and the ability to contact them for assistance if needed. Some companies have great communities where members can help each other. If you find a kit you like and there is a member support forum, help is never far away. When we first have the robot in hand, it will take some time to familiarize with it before we start creating our own activity ideas. So it's very helpful to have activities already available to help us start practicing and getting to know the robot. You may know better than me that it's very important that kids get engaged with the activity. Make sure that the kit you choose is engaging to students so they keep concentrated and to optimize the learning experience. In order to protect your investment, it will be great to have a kit that grows with your students' knowledge. Two options are available: the possibility of expansion or the possibility to perform new activities depending on the learning curve of the student. So consider if the kit you are looking at is a dead end, can be expanded upon, or at least has parts you can reuse later. Other important thing to consider is programming. If you have some coding experience, you may want to learn towards a kit that is based on a programming platform you are already familiar with, or you may look for kits from manufacturers that offer training for you. Always verify if the kits are suitable for your student's age. And the last but not the least important is the price. Based on the characteristics mentioned before, I'm going to present you some robots that are less known in Canada, but very popular in Europe because of their versatility and original designs. Let's start with Obot. I will present you a video of him presenting himself.
Hello. I am Robot. Program me to move, speak and behave like a human. Using a block programming language like Scratch. You can start off very simply and progress in easy stages to a fully behavioral robot. I come as a kit or as a ready-made robot. You will learn about interfacing computers with physical devices.
As you can see, Obot is a robot head that can be programmed to move, speak, and behave like a human. You can program it to move each of its 7 motors, read sensors, and type text for Obot to say. The system is available in 2 versions, Obot for Microsoft Windows and Obot for Raspberry Pi. In this webinar, we will concentrate in Obot for Microsoft Windows. It is provided as a kit that comes with full instructions so that it can be built by children aged 7 and older, or the other option is pre-assembled. I would recommend the first option, as building the robot will really help kids to understand how Obot works. They are much more likely to be able to fix it if anything comes loose in the future, but always with adult supervision when building the robot. Obot has 7 motors to allow a range of realistic movement, like head turn, head nod, eye turn, tilt, move lips, or blink. Obots are controlled by an Arduino board that allows for additional sensors to be used, which means sensors can be connected and accessed from within the programming environments. This opens lots of opportunities for learning. Obot can be programmed using a Scratch-based program. Any child who is familiar with the Scratch will immediately be able to control Obot. However, there is a ton of things to explore with it, so they will need some time to fully understand the robot programming. Obot also includes face recognition, so it can be programmed to react when it sees a person and follow their movements. As for training support, the manufacturer provides a Get Started course, so you are able to understand how the Obot programming works. There are also some code snippets and project ideas to help you create activities for your classroom. Obot is also supported by a large community. Let me present you Marty. Marty is a real walking robot. As the Obot, it comes as a kit or pre-built, so you can either choose the fun of building a robot or just jump straight into playing and coding with it. Building instructions are very easy. All packs include everything you need to build and program your very own Marty. It includes a screwdriver, rechargeable battery, and a USB charger. Your students can start programming Marty using a Scratch-based language as a Obot, and then advance to Python, JavaScript, and even ROS. As you can see, it is upgradable and can evolve with your kids' knowledge and abilities. You can also add a bunch of sensors to the robot, react to the environment. Marty can walk, turn, dance, and even kick a football. Marty is Wi-Fi enabled, so you can remote control it or program it using your tablet or computer. It comes with 9 individually controllable servo motors, and in my opinion, Marty makes learning about programming, electronics, and mechanical engineering a fun and engaging process. Is a very important characteristic of this robot is that he is customizable with 3D printed parts, and it is also upgradable. You can even add a Raspberry Pi computer and a camera. For support, you can find lesson plans, teacher training, and support in the web page. Marty is also supported by online tutorials and an online community. Some Labs is an STEM kit that enables kids to learn, explore, and code. Each kit contains different sets of interactive electronic blocks that connect wirelessly with the app. From the app, kids can code and experiment and see the block interaction on the screen. The electronic blocks bring the program alive. Let me show you the video how it works. Once you have connected and paired the electronic blocks, you create your own program and connect them in the app. This way you can see the result on the screen and live with the components. Each component has a specific function. There are inputs like the button, the light sensor, the tilt sensor, and the proximity sensor, and outputs like the motor, the servo, and the RGB LED. Unlike most electronic sets, some labs components do not need to be physically wired together. This is because each component has power, control, and connectivity bundled into a small package. The components are Bluetooth for wireless communication. The blocks are wired together using graphical software. The SumLabs kits enable students progression for different skill levels. They start with the visual flow-based coding, then progress to block-based coding using some Blockly, and it can also be advanced to JavaScript programming. The flow-based coding let kids program the inputs and outputs using commands for behaviors, logic, and timing. Detailed practical lesson plans made for teachers and by teachers, including learning outcome and assessments, are available at their webpage. The exercises can be adapted to the Canadian curriculum. Let's continue with Kubo. Kubo is an educational robot that accelerates learning in coding through its tactile programming language, which helps preschool and primary school children to explore and understand component new concepts as in a screen-free environment. The tactile programming language consists of puzzle pieces that offer different directions for Kubo to follow. Students connect the puzzle pieces any way they want, and Kubo then drives along the tiles to read the directions. There is a map that is provided with the Kubo, and it's the playground of the robot, where students can plan a journey for Kubo and use the tactile pieces to program the robot to get from A to B. There is also a blank map that is available to enable you and your students to create your own activity. With the basic kit, you will find root tactiles, functions tactiles, and loop tactiles. Using this material, kits can evolve in the programming process. Let me show you a video to present you how Kubo, the basic one, works. So in level 1, it's all about routes or movements, as the arrow in each tactile suggests. With these pieces, you can control the direction that Kubo moves by sequencing them together. Then level 2 is all about functions, which combine a series of instructions into a single line of code, then use the play tactile to execute the recorded commands. Finally, level 3 gets a bit more sophisticated with the instruction of loops, recursive functions, and subroutines. Then with the expansion set, Decoding Plus set, kids will be able to create advanced routes, functions, subroutines, or loops. They use completely new tactiles as wait 2, 5, or 10 seconds. They have speed control, go back, or U-turn. They have also go forward, turn 90 or 180 degrees, the record and play functions. I will show you how the advanced coding with Kubo works. For support for Kubo, you can go to their webpage and find a lot of information about lesson plans and activity ideas in many languages. Let's continue with our last robot for today. The name is Kibo, and it is a screen-free robot for kids between 4 to 7 years old. It is an easy and fun way to bring robotics and coding to your young learners. Kibo allows learning and teaching coding through manipulation of tangible objects, pieces that allow them to create sequences of coding, working elemental concepts of coding that can be transferred to other programming languages. It can be easily integrated to the childhood school curriculum and permits to explore the creativity, adding decorative elements to the robot. Kibo has a body where we can find its brain or motherboard, its power source, and the elements where we can connect the engines to turn the wheels to move Kibo. The upper part, we can connect the different sensors, like the proximity sensor, sound sensor, light sensor, or the actuators, like the motors, the light, or the sound. Kibo assembly is very easy and can be done by kids. The components of the robot are different sensors, as I told you, such as the distance sensor, the light sensor, or the sound sensor, and the outputs, the light bulb, and the motors. There are also the programming blocks that are begin and end instructions, movement, sound, for example, make a sound or wait for a sound, light, or more complex blocks such as a repeat or conditional blocks, including the parameters that can be used. There are also platforms or stages to work the creativity and let kids decorate it in order to work for different scenarios, narratives, characters, etc. Let me show you a video of Kibo. So after assembling Kibo, kids can create a sequence by putting the programming blocks together. Then they scan them and let Kibo perform the program. As you can see, Kibo is different from any other robot kit for young kids because it not only concentrates into coding, but integrates different inputs and outputs to help kids understand how a robot works. The manufacturer's webpage provides resources, professional development, curriculum ideas, and technical support. As you can see in this, I'm sorry, just a second. As you can see in this table, the robots we have provide all the characteristics that we are looking for when searching for a robot. Recommended ages are between 4 and 7 years old or more, and the price range can change depending on the type of kit you are looking for. If you want only one robot, you have a low price. But if you want to have kits for your classroom, like 20 or more units, you have the prices can vary between 4,000 and 8,000. Different languages can be used with the robots: Scratch, Python, JavaScript, ROS, flow-based programming, Blockly, or the tactile or block programming as in Kubo or Kibo. Well, this is the end of our webinar that is hosted by Merconet and Canadian Classroom. I hope that the information we shared with you is valuable for you and will help you when choosing your new robotics and coding kits for your classroom. If you ask questions, I will take some minutes after the end of the webinar to answer them. Thank you very much and have a nice day.